In problem 5, we are given the frequency response of a digital filter, and it's given in terms of the magnitude and the phase. We are asked to find h of n, the impulse response. So we are going to find h of n by taking the inverse dtft of He to the j omega. If you remember, we did a similar problem in class deriving the impulse response for a low pass filter, but that example was for zero phase. The phase there was flat 0, and the answer that we got was h of n is sine omega c n, where omega c is this cutoff, over pi n. Here the phase is not 0, and we can very easily get the answer using the same method. H of n is 1 over 2 pi integral minus pi to pi h e to the j omega e to the plus j omega n d omega. Now the magnitude response is 0 here and here, and it's equal to 1 between minus 3 pi by 4 to plus 3 pi by 4. So the limits of the integral end up being from minus 3 pi by 4 to plus 3 pi by 4, whatever the frequency response is, times e to the plus j omega n. Now the frequency response is the magnitude times e to the j phase, right? The magnitude in this interval is just 1, and the phase, we see that this is a straight line with a slope minus 1. So the equation for this line would just be minus omega, right? This is a straight line with the equation minus omega. So the frequency response written as a complex number by combining the magnitude and the phase is e to the negative j omega. Now solving this integral, first we simplify it a bit. We get e to the j omega n minus 1 d omega. To solve this integral, you remember this this integral equation, integral of e to the a omega d omega is e to the a omega over a, and later on in the next step it can be simplified into a sine or a cosine because of the way this is set up. If you remember, in the class the integral was between minus omega c to omega c, and it was just e to the j omega n instead of n minus 1. And the answer that we got for the low pass filter with 0 phase from class was sine omega c n over pi n. So instead of n, I can simply use n minus 1. So here this expression should produce sine The cutoff here is 3 pi over 4, 3 pi over 4 n minus 1 over pi times n minus 1. So we replaced all n's with n minus 1s, and this is very consistent with the, if you remember, we studied something called linear phase, where the phase was minus omega times nd, where this was supposed to be the delay of the filter. So here's your delay, n minus 1, and like we are given a linear phase. So this would end up looking like a sinc function that is shifted to 1. So it's not that hard. Part B, is it an FIR or an IIR filter? Again, n can take all values from negative infinity to infinity, so it extends both ways to infinity. So it's an IIR filter.